fazer cogeração, então você tem 3 a 4%. E, além disso, se fôssemos, hoje produz 600 milhões de toneladas de cana, você tem em torno de 300 milhões de bagaço com 50% de umidade. Se fosse, por exemplo, chegar no que vocês estão falando, e que na perspectiva do Brasil, do Programa de Energia do Brasil, para 2020, haveria necessidade de pelo menos 600 milhões de bagaço, ou seja, 1 milhão de toneladas de cana. Como equacionar isso?
So, I don't know if the presenters got the question right. I don't know, perhaps, Lee, you can build on this question, is about the availability and the feasibility of producing second generation from bagasse that perhaps is not available at all.
Okay, my guess is that the best answer to your question can be collaborative. So I'm going to answer one piece, or I'm going to address one piece of it, and I anticipate that my colleagues can perhaps address some of the Brazil-specific aspects more. And this is, in a way, a Brazil-specific aspect, but I've spoken to many people about what goes on in sugar mills and ethanol mills, and I think the consensus view is that in the absence of an opportunity to derive value from bagasse, there's not much extra. Plants are basically in balance with respect to bagasse. So if you look around today, you go, well, gee, there's only 2 or 3% extra, which is actually almost not extra, because that's sort of the margin that they always have enough, if you know what I mean. And so at the same time, if you ask, well, how much does what's happening at that plant actually require if there was an opportunity to get other value from the bagasse? And the answer is an awful lot less bagasse than you have available now. So is that available free? No. It will take investment. And if I implied you didn't, I didn't mean to imply that. I think that's fairly broadly understood. Let me suggest that one of my colleagues address some of the aspects about sort of the volume, but I wanted to address the part as far as inside the plant.
Yeah, I just want to say one thing about the numbers. First of all, you don't need to burn the bagasse. You can ferment the bagasse and burn the lignin. The lignin, which is the non-cellulosic part of the bagasse, will contain most of the calorific value. So when you burn the bagasse today, you burn lignin, you burn cellulose and hemicellulose. If you take the cellulose and hemicellulose out, you reduce the power, the calorific power of the leftover, not very much. What is important is you burn the lignin, which is 5,500 kilocalories per kilo. So lignin will provide most of the energy no matter what. What you extract is the value of the bagasse, that is the cellulose and the hemicellulose. So my proposal would be, instead of sending the bagasse to burner, send it to fermentation. You ferment that part, hydrolyze and ferment that part. You have a 30% left over, which will have 65 to 70% of the calorific power. So your equilibrium will be found again by just a little bit of external aid from additional bagasse, not much, because the rest will come from the existing bagasse that you have in your mill.
Anyone in the panel want to add? Okay, so do you have another question? We have time for just one question. Aqui, por favor. Desculpa, sorry, já está lá, então vamos fazer duas perguntas muito rápidas e duas respostas, two answers very, very fast, okay? Because we are being asked to leave. Então, sua pergunta primeiro, depois aqui terminamos.
Boa tarde, é Luiz Cunali, da usina Ipiranga. Primeiro eu gostaria de fazer uma pergunta. Comentaram bastante a respeito do pré-tratamento e pouco da fermentação de pentoses. Eu gostaria de saber um pouquinho da fermentação de pentose, se isso já está esclarecido, se já é uma barreira já cumprida, que não tem problema nenhum com a fermentação dessas pentoses aí da celulose e hemicelulose.
E essa é a sua pergunta a respeito das pentoses. Norberto, você quer responder, por favor?
Sempre existe o desafio de melhorar a fermentação de pentose e exoses, né? Mas o que eu estou vendo como tendência é a fermentação conjunta de exose e pentose, e isso, junto com os nossos parceiros, fornecedores dos insumos, eu acho que a gente está resolvendo bem. Eu acho que não só nós, no nosso desenvolvimento, mas eu acho que os desenvolvimentos tecnológicos em geral estão resolvendo bem. Eu acho que não é um grande problema agora.
Guido wants to add if Lee also would please make a short comment on C5
O
fermentation.
Lee vai ter outra resposta.
In the current technology we are presenting, the C5 will be fermented as much as the C6 in the same time with the same percentage of fermentation. So this problem, to me, is solved.
Lee, would you please?
Wait, let's go to the other question, please.
Ok.
Okay.
Sua próxima pergunta, por favor.
So my question is a little bit different for you regarding something concerning the ethanol sustainability. Very few people in this room know about vinasse. But you know very well the problem. And when we talk about the Brazilian sewage, domestic sewage, we are talking about at least 400 million liters a year. Even more if we consider all the rest of the sewage. When we talk about 25 billion liters ethanol, we're talking about at least something 13 times more vinasse, which is an industrial wastewater flow, if you look to the composition of vinasse. We know that we are struggling to produce much more with the second generation. The second generation ethanol is a good idea. But our vinasse should continue to be first generation vinasse. And this is industrial wastewater. So it's not time to take care of this problem, because the corn ethanol in the US does not have the similar problem. It's a completely different quantities and volume. But the absurdity of the volume of vinasse here, it is a scandal that very few people know about it. So, despite fertigation, which supposedly absorb the majority of the vinasse, at least 60% is not really used through fertigation. So, I wonder if you abroad know about this problem, and what are you doing regarding that? Because a lot of investment to produce more, and the field is crying. That's my question, particularly to PETROBRAS, which really disappoints a little on the investment regarding vinasse.
Ok. Norberto, você quer responder? Senão eu também posso.
A gente pode responder depois.
Ok. So I will begin trying to answer your question. And
My question mostly to the U.S. perception would be great for me as well.
Okay. So perhaps then Lynd can add.
So I understand that the question is about essentially the water leaving the facility, correct?
Yes, industrial wastewater flow.
Yes. So, and you mentioned, I believe correctly, that the situation is different in the United States from the ethanol industry here.
Corn.
There are corn ethanol mills that essentially only lose water by evaporation. They have very close to 100% internal water recycle.
That's true.
And so there are also people in this room who know more about the current practice of disposal of vinasse than I do, so I'm going to try to not get in trouble there, okay? But
good.
let me offer the general perspective that as we think, as I and other people in this room with whom I work and elsewhere in the world, as we think about much, much larger volumes of bioenergy and biofuel production, we will indeed need to pay more attention to some issues that just aren't such a big deal at small scale. And I think two of them, one of them you mentioned, which in general is the water balance, and I think where we need to go is to not have once-through water use, but to have extensive water reuse, which means you need to take the things out of the water that prevent it from being reused. Generically, that's not a complete answer, but it's a strategic direction. I would add the same thing is true with respect to fertilizer. We don't want to have once-through fertilizer use, but we want to recover these elements and figure out how to put them back on the field. And those will be, in order for this industry to grow by orders of magnitude, which I believe it has the potential to do globally, we will simply have to face those problems. And Brito has referred to the importance of the sustainability issues. Directionally, I agree.
I have a technical answer for you. Have you ever heard of Torula East? You evaporate the water that you have in the vinasse. You implant.
Yes, it costs R$4 per cubic meter of vinasse.
I beg your pardon?
I know the production cost of evaporation of that.
In most of the other countries, like Venezuela and so, you implant Torula East and you produce an animal feed, so you don't discharge any water. You recycle the water there. And that solution is quite efficient if you have enough money to invest.
Correct.
Foi bem lembrado porque nós temos uma linha de desenvolvimento tecnológico para o que a gente chama de novos usos para vinhaça, e uma linha grande de pesquisa com parceiros, com universidades no país e no exterior. Isso é caracterizado dentro da Petrobras e com os parceiros como novos usos para vinhaça, né? Eu vou te dar um exemplo, os outros tem alguns que a gente não fala, mas tem um que a gente está em planta piloto, por exemplo, que nós estamos fermentando vinhaça para produção de hidrogênio, em planta piloto já, né? Então nós temos um investimento grande e existem boas novas perspectivas de uso para vinhaça. A vinhaça é mais ou menos um primo da glicerina, né?
São 800 vezes mais do que todo o esgoto doméstico nacional.
É.
Então, você imagina, 800 vezes o que 200 milhões de pessoas estão produzindo no seu toalete diariamente.
Mas existe uma linha grande de pesquisa com várias linhas de desenvolvimento e estamos trabalhando para ter novos usos para vinhaça.
Isso devia ser uma prioridade.
É prioridade. Não deveria, é prioridade.
Exatamente. Tão ou mais do que produzir mais etanol.
Ok.
É prioridade.
Nós temos um problema de tempo. Eu gostaria de agradecer sinceramente aos meus colegas e a vocês. Muito obrigado.